Good morning and namaste. A very warm welcome to each one of you to the culminating day of the 8th edition of the TSDSI Tech Deep Dive Conference 2025. We are truly delighted to have your presence both in person and virtually as we arrive at the final day of this significant conference that has sparked impactful conversations around our theme, standardizing 6G, architecting intelligent, secure, and sustainable network and services. My name is Shefali Sinha, and I, along with my colleagues, Ms. Bindu Srivastav, Ms. Chandrakanta Rathore, Ms. Anupam Sinha, and Ms. Ritika Dio, will be your hosts for today's proceedings. Before we commence with the much anticipated sessions, here are a few hygiene announcements to ensure a smooth and enriching experience for everyone. The conference is being conducted in hybrid mode. If you're joining us online and wish to ask a question, please type it in the Q&A or questions tab on the LME platform. All sessions are being recorded and will be available on the TSDSI website in the coming days. Speakers, we kindly request you to adhere to the allotted time slots for your presentations. We have a power-packed schedule for today, which includes an opening section, workshop on new networks and services ecosystem for 6G services aspects, featuring experts from ITU, 6G Brazil, 3GPP, HC, DSCI, NSUT, and ETRI. Workshop on new networks and services ecosystem for 6G networks aspects with distinguished speakers from ITU, Samir, NCC, NextG Alliance, and Bharat 6G Alliance. Summary of TTDD technical deliberations, presentation of the TSDSI Outstanding Technical Contributions Awards for financial year 24-25, and a special session on standardizing 6G the way forward, graced by Professor Abhay Karandikar, Secretary, Department of Science and Technology, and Dr. Neeraj Mittal, Chairman DCC and Secretary, Telecom, Department of Telecommunications. To formally open today's proceedings, may I request our esteemed speakers to kindly come up on the dais. Dr. Hideyuki Iwata, President and Director General of DTC and Chairman and Vice Chair of ASTA. Mr. Rajesh Pathak, Director General of Bharat 6G Alliance. Mr. A.K. Mittal, Director General, TSDSI. Professor Bhaskar Ramamurthy, former Chair of TSDSI and Professor Emeritus in the Department of Electrical. To invite Mr. A.K. Mittal, Director General, TSDSI, to deliver the welcome address. Shri A.K. Mittal currently serves as the Director General of the Telecommunications Standards Development Society India, TSDSI. He is also associated with TSDSI as an advisor focusing on standardization in wireless and wireline systems and represents TSDSI in 3GPP and ITUR activities. He began his career in R&D at Indian Telephone Industries Limited and later joined the Department of Telecommunications, DoT, Government of India, where he worked across domains like satellite communication, optical fiber, microwave, mobile networks, licensing, regulation, standards, testing, and certification. He has represented India at several international platforms. Sir, the floor is yours.
Thank you, Shefali. Good morning, everyone. Present here and people joining online. So distinguished speakers here, the dais, Iwata-san, Mr. Pathak, Professor Bhaskar, who is online, and all the distinguished guests, ladies and gentlemen. You are welcome to this concluding day session of TTDD 2025, which is a flagship conference of TSDSI, which is now running into 8th year. And this conference this year has been very successful compared to the previous year. We had 880, around 880 registrations for the conference and 550 plus delegates joining in remotely, different numbers in different sessions. And the first session itself saw about 260 participation, and participation never fell below 150. So this has shown that the interest people take and the value the delegates provide to this conference, which enriches the knowledge of people, because we have invited international and national experts who provide their deep inside view of the technology and the trends and what is going to come in 6G. The work in TSDSI on 6G started back into 2020 when the IMP 2020 or 5G was just finalized and released by ITU. And since then, we have come a long way. We released a report on 6G use cases and technologies, and based on which we contributed to ITU's recommendations on 6G framework or IMP 2030 framework. And currently also, because of the ongoing work, we are contributing to the definition of technical performance requirements of 6G, and also the evaluation methods and other aspects of 6G. So, and a number of items on 6G standardization and studies on the different technology aspects are under study under works in the study groups, and more will come. And we feel that the outcome of this DTDD, when you will see in the afternoon session, in the session summary, that will provide us inputs to TSDSI for taking up additional work or refining its work within TSDSI. And TTDD has been, as far as 6G is concerned, it has been a step-by-step logical progression. 6G, we had in TTDD 2023, we had the title because 6G was just on the horizon at that time. So we had the title as 6G Horizons, Converging Technologies for Connected Society. And next year we did 6G Vision, Societal Needs, Usage Scenarios and Technologies. And this year, as a natural progression, we have done standardizing 6G, architecting intelligent, secure and sustainable networks and services. So it is not only keeping pace with what is happening in the world, the way 6G is progressing, but also that we want to go a step ahead based on the inputs available from this conference and the work being done by our members in different areas of 6G. So we had online sessions in this conference on network management, delivery, service delivery aspects, AI, integration of non-terrestrial and terrestrial networks, their challenges and the way forward, the likely waveforms, security, and other aspects. So you will see interesting summaries of the sessions, which have good, very interesting and promising takeaways where all of us, can give a thought and apply ourselves to work further. And in this day today, we will also have a session on outstanding technical contribution awards, which is given to the delegates who have given outstanding contributions, resulting into release of technical reports and technical standards. We at TSDSI also adopt standards from 3GPP because we are a partner of 3GPP and 1M2M. So it is actually, we are the owners of that, co-owners of those standards. So we transpose and publish them as TSDSI standards, and Telecom Engineering Center adopts them as national standards by following the due process. Currently, we are very active in ITUR with contributions. Our members are actively contributing there, and there's a buzz of activities here inside. I think I can go on and explain the work in TSDSI, what is happening and what we intend to do. But I think during the day, when you have here the experts in the workshops on networks and also on services, you have a better idea that what we are going to, what is in store for us for future, and we are ready for those challenges. And you will also be happy to know that Secretary Telecom and Secretary Department of Science and Technology both have agreed to be here to grace the occasion in the afternoon session, evening session, of course, at beyond 4 o'clock. and kindly be here, listen to them, and listen to some very informative and interesting aspects of 6G. We have Chef Ali has already, mentioned the lineup of speakers which we have from different organizations and countries for today's deliberations. So thank you once again. All of us are ready and we are very eager to hear all the speakers. Thank you very much. Have a good day.
Thank you, sir. I'm now delighted to welcome Professor Bhaskar Ramamurthy to deliver his address on India's role in standards and ecosystem readiness towards 6G. Professor Bhaskar Ramamurthy is former chair of TSDSI and Professor Emeritus in the Department of Electrical Engineering at IIT Madras. He served as Director of IIT Madras and has been a key architect in India's telecom standardization journey. As a founding member of TSDSI, he played a pivotal role in shaping its vision and international engagement. He specializes in wireless networks and signal processing and led the nationally significant 5G testbed project. He currently heads the Center of Excellence in Wireless Technology, CIVIT. Sir, the stage is yours.
Thank you. Am I audible? Just a quick check.
Yes, sir.
Okay. So thank you for putting my presentation on the screen. Good morning to everybody, those who are present in the auditorium there and those who are online. Glad to be part of this tech deep dive, which has been running successfully every year. TSDSI is being the driving force. And I just spent a few minutes talking about India's role in standards and ecosystem readiness for 6G. So from India, we've been active in standardization for the last 15 years or so, of which 10 years TSDSI has been in place and has been very active organizational partner of 3GPP and is very active in 1M, 2M and IEEE and so on. And it plays a leading role in making sure that the standards that are developed have contributions from India, particularly to take care of any requirements that are important for India, specific to India maybe, given that we have such a huge population and very unique geographical spread and population density, huge rural population, but with fairly high population density. And how does one make sure that the telecom standards that are developed generation after generation are how do you ensure that they also meet the requirements of this large population of a growing country? So I will now spend a few minutes and a few slides talking about India's role in standardization for 6G and also the ecosystem readiness. Next slide, please. India promulgated a vision for 6G for itself. India is also called Bharat, so this is called Bharat 6G Vision. And this was released by our Honorable Prime Minister 2 years ago. And basically, in a nutshell, we want to make sure that technological advances in 6G impact not just the coolness factors of user experience, which is a sort of a global desire of all countries and all people who want 6G. They want a better experience. They want a much more seamless and user-friendly experience. But we also want to, from India's point, we also want something that impacts the lives and livelihoods of the users, because the mobile phone has been a huge game changer in India from an economic standpoint, from the point of view of people who are rising up the income level ladder and going from poverty to better living standards. And from that point of view, in ITU, India has been piloting 3 main requirements from 6G. One, that it should be affordable, and second, that it should. So basically, it should also enable, as far as possible, through innovations, remote skill services, all kinds of where it can affect livelihoods, both essentially by improving the human-machine and machine-machine communications, with high reliability and low latency. If the 6G systems can do this, automatically use cases will emerge where skilled services can be offered in part or in full using the 6G technology. We also wanted to be ubiquitous. We continue to have coverage holes in the country. There is large dispersed rural populations. We continue to have that for various reasons through the generations of technology from 2G up to 5G. We want to make sure that with the innovations that are coming up in 6G, that we have ubiquitous broadband connectivity and to the mobile phone. And we also wanted to be sustainable. I think this is an important goal across all verticals of the economy. As we grow, we don't want to get into a situation where we are in an unsustainable environment. Next. So the must-haves are that, NTN, non-terrestrial networks, and integration with the terrestrial network is a very important part of 6G. Work has already started in 5G Advanced. But we want this to focus as much on ubiquitous coverage as on ensuring that you get coverage from unpopulated areas like the open seas or the deserts or hills and so on, which is important for a small subset of the population which has various reasons to travel to these areas. But we actually have substantial numbers, millions of people living with a very comparatively lower population density across areas where it has not been viable economically to extend the terrestrial network, or it's semi-forested or with not very poor propagation. We want to see how NTN integration with terrestrial can actually close all these coverage holes using LEO satellites, because we want broadband, probably using LEO satellites, but also as the technologies improve, using pseudo satellites like HAPS. We want a mobile broadband network with as high a spectral efficiency as possible at the point at which it is deployed, because spectrum is limited. We have a very huge population with a high population density. Spectral efficiency becomes very important. And from the point of view of the ease of deployability and flexibility, we would like RAN virtualization right up to the tower and a low energy footprint to improve sustainability. Spectrum is scarce, especially if the vast majority of the population depends only on mobile technology for broadband. They don't have wired broadband. Then we want to also encourage shared use of spectrum, particularly in NTN, to ensure ubiquitous coverage. But also maybe some kind of coexistence as we go into new bands with technologies where the two systems can coexist and operate without interference to each other. But most importantly for NTN, we must ensure that because NTN networks have large footprints and shared use of spectrum becomes very critical. One would wish also to have new sensors and devices that will enable tactile internet, AR, VR, ambient awareness, and so on, because this will go a long way towards enabling skilled services to be offered through online. And I think we have not had any major breakthroughs in sensors and devices for almost 10 years now. This is something that also we would wish for, but if it doesn't happen, it doesn't matter. The must-haves are what's really critical. Next. Yeah, it's not easy now to add new spectrum in the nice bands. What I mean by nice bands is bands that are amenable to mobile communications. Let's say roughly below 4 gigahertz, but actually it's below 2.5 gigahertz. But we can just about manage to go up to about 3.54 gigahertz and still get reasonable penetration into buildings and reasonable coverage. The second thing that has happened is single cell MIMO and 1:1 reuse are reaching the limits of spectral efficiency. Yes, we can tweak a little bit more, but it's not going to be huge factors of improvement. Besides, MIMO is energy intensive. Actually, MIMO relies on scattering energy in multiple directions so that you can get multiple parallel streams to the user from these different paths that the signal energy takes from the transmitter to the receiver. But this is inherently energy intensive. For sustainability, we need to focus more energy towards the user to whom the signal is intended. Beamforming becomes more important. I think we're looking at beamforming techniques playing a bigger role going forward in 6G and thereafter. And then finally, to increase capacity, we need to move towards cell-free connectivity with multiple links mobile stocking, not just to one cell, but to multiple cells to get the traffic, get the higher capacity. Also in parallel, more fiber penetration, denser cells, and more virtualization of RAN. Next slide. For ubiquitous connectivity, I want to emphasize that despite adding lakhs, when I say lakhs, there's millions of sites, 500,000 to 1 million sites. India still has substantial areas with poor coverage, particularly in forested areas, deserts, hill dwellings. And seamless integration of NTN, as I already mentioned, both using LEO and pseudo satellites, becomes very important for ubiquitous connectivity. And in the 6G standardization, we are looking at strongly at how to make sure this happens. Next. So in India's role in 6G standardization is that in ITU, we are focusing very strongly on ubiquitous coverage, as I just mentioned. We want to make sure the requirements actually ensure 100% coverage of our country, and actually for all geographies in the world, using a combination of terrestrial and non-terrestrial networks. We also want to study ubiquitous urban coverage. There are problems in urban coverage also in dense urban areas in the other extreme. And we would like to see how RIS could be used. And TSDSI is actually having a fairly large effort on this, how to use RIS to get better urban coverage. And the Indian entities in 3GPP are contributing strongly towards increased spectral efficiency through better waveforms, use of AI/ML at all network layers, from physical layer right up to the network management layer, to improve system efficiency and to improve sustainability, conserving energy wherever possible. And then, as I said, new ideas like ambient IoT, network sensing, and so on, to actually try to get better device awareness, so that it will be possible for man-machine interaction and skill services to be offered online, along with the improvement in data rates and flexibility and use of AI/ML extensively in the network. So the idea is these techniques which are being studied in 3GPP, which are relevant to those focus areas, must-haves that I talked about, that's where India's role in 6G standardization is going to be focused on. Next. The ecosystem in India is an evolving ecosystem from a situation in about 7-8 years ago, where we hardly manufactured any of the equipment that goes into these networks in the country, and also usually deployed the latest generation of telecom technology about 4, 5 years, 6 years after it's been released elsewhere in the world. Things have changed. In this last decade, 5G was rolled out in India by 2023, among the fastest in the world. Telecom systems and device manufacturing have also ramped up very rapidly in the last 3 years, all the way from the radio access networks to the core to phones, IoT devices, and so on. The space and drone sectors independently have been growing very rapidly. A lot of startups in the space sector, a lot of startups in the drone sector. And these are very important for NTN, both for launching low Earth orbit satellites at a disruptive cost point, and for coming up with the viable solutions for pseudo satellites. So by 2030, I think we can expect very innovative devices in network components that emerge from India, which actually focus on increasing affordability, addressing new use cases, particularly those that affect livelihoods rather than just communication quality, and also improve sustainability. Do all of this at low energy footprint, both from a sustainability point of view and also from an affordability point of view. And we expect that the space sector, which is growing very rapidly, independently of what the efforts in the telecom sector, will disrupt the LEO satellite cost. The number of startups are emerging which can launch low-weight LEO satellites at very, very disruptive price points. And drone innovations that are moving very rapidly ahead, we expect that they will make HAPS both technically and economically feasible, so that you can actually position pseudo satellites above various counties and districts where there are large coverage holes, and provide ubiquitous coverage. Next. As an umbrella organization to make sure that all these efforts are aligned with each other, the Bharat 6G Alliance was formed about 2 years ago. This is to ensure that 6G technology is a force multiplier in the Indian economy in the coming decade. enable India to become a leading innovator of advanced, sustainable, and affordable systems and solutions, particularly public goods that vastly improve lives and livelihoods, and ensure that India contributes significantly to meeting the IMT 2030 requirements of ubiquity, sustainability, and affordability, which have been piloted strongly by India and ITU. So this alliance is an alliance of companies and startups and some research organizations. Make sure that all the efforts in the country which are done, which are being taken up by various entities, are as far as possible coherently aligned, and also to liaise with the government so that the government's own efforts to catalyze all these efforts, to incentivize all these efforts, are also aligned with, so that we get maximum bang for the buck. Next. Yeah, I hope this gives an idea about how India and Indian organizations have, as from what I can make out, see their efforts in 6G, and how we hope to align their efforts and make sure that in 5 years we have something that's a substantial change from what is available today. Technologies up to 5G. Thank you very much.
Thank you, Professor Bhaskar. I'm now honored to invite Dr. Hideyuki Iwata, President and Director General of TTC and Vice Chair of ASTAC, to speak on Japan's approach and insights on 6G standards. Dr. Hideyuki Iwata is President and Director General of the Telecommunication Technology Committee (TTC) and serves as Vice Chair of ASTAC. Since joining NTT in 1991, he has led leadership roles in R&D and standardization, and has significantly contributed to international ICT standards, including as chairman of the HCGP Forum. The stage is yours, Dr. Iwata.
Okay, good morning, everyone. Thank you very much opportunity to this presentation. This is Iwata from TTC Japan. Next, please. I'd like to talk about our organization first. TTC is a standardization organization and non-profit organization in Japan. TTC is qualified in ITU-T as defined in recommendation 8.5, and instead of the 8.6 in 8.25 that can refer to ITU-T recommendations as a standard. TTC is established in 1985. This year is 40 years anniversary. And our office is located in Tokyo, Japan, near the old Tokyo Tower. Please contact me to the introducing the old Tokyo Towers. Okay, and we have 18 technical working groups. We are discussing technical standardizations. Next, please. I explained in activity, and this is important to the organization structure of standardization activity in Japan, because this is a different situation in the other countries. TTC in charge of the mainly to the ITU-T fixed network standardizations. Web in ARIC is in charge of the ITU-R, and also to the GCTEA, to cable technical organization, is all previous in ITU-T SG9, now SG21. In charge of the standardization activities. And government in the MIC Japan in charge of the ITU-T. Other hand, in the ISO IC JGC1, METI is charge of this standardization activity, and also to the all TCSG national body is a lot of national body, about in the 300 national body to discuss in the standardization issues. Japanese company to contribute in the separate in the contribution to the standardization organization. This is situation in Japan. Please understand. Next, please. This is our ITU-T standardization developed activity. Our position is discussion place in domestic standardization in to the ITT recommendations. And we discussed in contribution to the ITT. And after that, in MRC, international communication to council in discuss to the proposal and endorse and to the ITT to the TTC discussion proposal. This is the upstream activity. And also TTC have ITT recommendation to the transfer to Japanese standards. This is what we call to the downstream activities. A lot of the TTC standards, about half of the TTC standards is based on the ITT recommendations. Next, please. Firstly, I explained in the XG Mobile Promotion Forum, this is standardization in 6G and beyond 5G. This is previously to the we have in the 5G mobile consortium forum, and also to the we have to the beyond 5G promotion consortium. Last year, two organizations is merged and establishing XG Mobile Promotion Forum. And if you want to the information in detail, please access the official website. Next, please. This activity is basically to the project base. Now it's 20 projects in for on. This is based on a proposal from the company to the leader to the making progress to the promote in 6G or beyond 5G technology. Next, please. And also to the global collaboration, like XG Mobile Promotion Forum. This is to succeed in mobile 5G forum to MOU. And in the now it's maybe to the in May, maybe to additional to MOU to in XG forum between the other organizations. Next, please. This is our beyond 5G and 6G activities. We are establishing TTC ION Global Forum working group committees. This is basically to in activity of the ION Global Forum. This is all optical photonics network and something with the new technology to this in the technology. Also to ITT, TSB Director Onoe-san to have every year in a round table, high-level IoT meeting. Onoe-san said in this activity the benefits in providing ITT activity in gathering in industry. And next, please. We are establishing TTC ION Global Forum Group. In mainly, we TTC has established in the last year this committee based in activity on ION Global Forum related to the contributing IQT SG5, SG12, and SG13, SG15, and SG17, SG20. Firstly, we have planned to start point in delivered to the framework, network framework to the SG13 and IQT. And also downstream activities, IQT recommendation and ION Global Forum technical material to the transfer to Japan is in TTC. Now is just in architecture, but in next step, we are planning to expand it in other areas, other SG, and also to the we are promoting young generation techno experts to the like beyond 5G and 6G areas. Next, please. And this is an example is ITT SG13 activities. This is a work item. title is ITT Y.L2E2 and net FRM, is in the framework. Low latency and energy efficient communicating in internet networks. This is started in last year and will be to determine 2026. And the supported member is KDDI, NTT, Oki, Sumitomo, Sony, Fujitsu NC, and other organizations, international organizations. Next, please. This is a framework to the standardization. This is background is described, and also to the what is L2E2 networks. Please to describe this one. Next, please. And this time is the high level requirements in we discussion in IoT, and requirements use case specified existing IoT specifications related to AI, and also to the immersive live experience and digital twins, etc. Lawless connectivity, topological flexibility and collection, lifetime installation, agility, and merged domain internet working and operation, administration, maintenance, and interoperability with no L2E2 networks. Next, please. And this next in item in TTC activity is to the PM5G60. This is SDO trend in QKD standardization. International organization already discussed in the QKD and in the IQT, SD13, SD17, SD11, also to ETSI, to the QKD group to discussion, and also to the ISO ICGTC1 discussing QKD device safety virtual method service. Also in Japan, to the quantum forum to promote to the quantum key distribution technology. And TTC developed of the national standards based on ITT recommendations, and such as JT3800 in network vision, security, and signal control expert community in TTC. Next, please. This is a recommendation related to QKD network contribution by Japan, mainly contribution from to the NICT. We have already to the SD13, SD17, and SD11 in the network access issue and security issue and protocol issue. We have contributed by Japan and QKD and networks. Next, please. Also, this is a TTC standard related to QKD network. We have already 9 TTC standards based on ITT recommendation, Y series and X series, network issue and security issue. Next, please. Finally, I explain to the TTC seminar NTN technologies. Last year, we have 3 TTC seminars. One is 5G society and industry, how to use NTN networks. And another one is actual disaster response in Noto earthquake, the latest trend of the disaster prevent technology. This is using to the NTN networks. And also to the workshop on NTN and the satellite communication utilization in IoT. This is already a free seminar to related NTN technology. Also, next month, we have the potential of the MCT for the future towards the secure world resilient to natural disasters using to the MCT network. This is just in a seminar, just in share the information. We're looking for the standardization to topics in NTN. Now it's a process to the discussion process, not to develop in the NTN standardization in TTC. Okay, thank you very much. In next, please to the if you have a comment in Vishnu, please come to me. Thank you very much.
Thank you, Dr. Rivata-san. Now I invite Dr. Rakesh Pathak to deliver a talk on enabling India to become a leading global supplier of affordable 5G and 6G solutions. Mr. R.K. Pathak, Director General of Bharat 6G Alliance, joined the Government of India in 1987. He played a pivotal role in shaping India's telecom policy and innovation landscape, a key architect of TSDSI, TEPC, and the 5G India roadmap. He led landmark initiatives including the PLI scheme, Digital Communication Innovation Square, and the formulation of India's 6G vision. He has championed indigenous manufacturing, global standards leadership, and startup innovation, steering India's emergence as a powerhouse in next generation telecom technologies. Sir, the floor is yours.
पॉइंटर चलेगा ना दिखेगा क्या good morning and thank you TSDSI for bringing me back to TSDSI events. So whenever I come with TSDSI, it's a better home itself. Can you just start my slide, please? So the topic have been that perhaps what will be the output of this tech deep dive, that what should be the direction for India at a national and global level in case for emerging technologies. Can I see my slides here or I have to see there? Because here it's not work. It's something. Anyway, I think no issue. I thought I was going by this. So I'll be trying to cover the Bharat 6G vision alliance, which has already been covered. So I'll be skipping those because I think we have to save time. So can you just go to the, let me just see if I can see the okay. Okay, no issue. Anyway, I think Bharat 6G vision has already been explained by one professor, and we both were together when we were drafting the Bharat 6G vision. So I think he knows more than me. But what is important that in case of 4G, 5G, earlier generations of technology, we are not part of the development. So it means India's requirements were not factored in. When the technology requirements were being looked into by the global forums. So for the first time in case of 5G, we tried to catch and we launched 5G in 2022. In 6G, with the help of TSDSI, we have been able to, and with the government and industry, factor our requirements, special requirements. It may be the rural areas, it may be the some dense urban populations of the list 6 in the 6G requirements, and we are continuously doing that.
Hello, yes, sir.
This is a new leadership of Bharat 6G Alliance. Presently, we have elected a governing council.
Yes.
Professor David Goel Pillai,
We are just running 15 minutes
is the
late for
chairman.
our workshop.
Kumar Sivarajan, and we have 2 vice chairmen. Kumar Sivarajan and Rohit Buddhiraja of IIT Kanpur. And you will see that we have a lot of young companies also,
So it is in the ground floor of RNA.
like Ichilan Age, Lekha Wireless, with Green and Niral. They have also joined the governing council, including HFCL, I can see. In addition, we have 9 government departments to give us the strategic direction. Because I think we have certain lessons from 5G. Because I think whatever the one of the reason of not picking up the use case, that user message department, they never thought that even wireless connectivity or telecom is their subject. So whenever we are going there as a government, by the time I was also part of the government, they were thinking that this is something to be done by industry, and they have no role to play. But I think it's very important that TSDSI or Bharat 6G Alliance or similar initiatives, it has to be the whole of the government approach. It means other ministries, department, wherever there is center of excellence, they should closely work with such institutions. And there is one confusion. People feel that I have set up research centers and that will do the once we have set up the research centers and that's our job is complete, and those center of excellence, they will do the patent also, IPR also. But I realized that there is no relations direct with the research and patent and standards. I think they are two distinct and we have to manage them if you want to get some tangible output. And that's why even the research institutions like IITs, they do the very excellent best. But whenever it comes to the standard, they write patent, then they write patent just to get the next funding. But those are not the quality patents to whom you can convert to. And if they are not participating in standard, they are not aware of what is happening in standard. So there is no direct linkage. So this is a time that we have to sensitize tier 1, tier 2, tier 3 academic institutions where there is a lot of government funding, and how the funding can be channelized to national champions, startups, MSMEs, by the government. Because I think we don't have the surplus money. If you ask any startup, he's just surviving. So a lot of government support without asking so many questions is necessary, and perhaps some changes in GFR will also be necessary. Though I'm discussing the lessons learned, but I know that people are more aware of lessons learned from 5G. So I'm just giving my thought process because I have 10 minutes time. As far as lessons is concerned, I think in 5G there were so many options that you do 5G SA, 5G NSA, true 5G, and option 1, option 2, option 3. People are thinking, and that's no subject of TSDSI, not mine, that I think there will be a simple 6G. If I have to say, then I will say that it has to be intent-based design. And if there is a zero data, something flowing, then that it should be power consumption should also be 0, not 80%. Because I think you will see that you switch off certain things, then also minimum power consumed is 80%. So how can we do such? And that is the challenge our IITs or other institutions has to take. That how can I design a system? Because people are saying AI. Once you are saying AI at all the places, and at the same time you are saying sustainable and low power and all those things. So I think a lot of work will be required in this direction. So this lessons learned, I think I'm just giving you the thoughts I need to decide.
I'm just checking.
This is very much important. Here, I think I would like to take some time. Government has all the enabling provisions today. It's just maybe the implementation, and I think we have to closely work, empower them to do it. One of the best scheme is the Telecom Technology Development Fund, where they can fund large projects and about 600 crores, about means $75 million dollars per annum, and that's a very huge sum. And they have already done some 120 projects, giving about similar amounts for the 6G test beds and 6G projects.
owners and the
But
joint
more has to be done under that itself. We have some 2 consortium projects on Open RAN and so many others by individual companies. It's already going on Open RAN. Whether that will be success or failure, it's not the matter. Whenever I discuss that I think we are part of innovation. We are not liking and we are not the user. Maybe those protocols, whatever we are discussing for the Open RAN, that will be utilized for our benefit somewhere else. Welcome 2023. But more important has been that government has already doing a lot of reforms, and one of the best reforms I can remember was the spectrum reforms, in which they decided to give in $75, 5,000 rupees, any test spectrum, whether that is required by TSPs when we were doing the 5G trials, or it can be for the lab environment below 100 milliwatts. So those were the best reforms and is still continuing. Even today, if you require any spectrum for technology tracks, you can just download, upload today, and by evening you can get it for demonstration purpose. That's the first and foremost reforms. They have already PLI scheme, production linked incentive scheme, but more important has been the design linked incentive scheme, in which they give one more percent incentive to those companies who completely design, have the software control know-how and know why. And that's there are 42 companies and 17 were design led. Regulatory sandbox, the policy has already been announced. However, we have not been utilized it to our benefits. Maybe some problem with the us itself. So we have to again go to the government if there is some problem, including CNPN. People say that CNPN operators are not working. So there is some problem definitely. So we can't sit. It's more than 2 years and there is no CNPN networks being rolled out by any our entities, which has potential to generate at least 1 lakh employment and more than 10,000 your CNPN systems. This is a slides I just thought that I should project here, because whatever we are expecting from technology, nothing to do with the 6G. It's all that we have certain missions and how can we utilize our benefits for digital inclusion, our digital economy. So whether you talk about the digital health mission, smart city mission, AgriStack ENAM, Skill India and digital education, or BharatNet and PM Wani. I think here our thought process has been that how can we utilize connectivity to our benefits, and we have seen in case of our payment systems, JAM, Trinity. So government and industry has to work together in the forums like Bharat 6G Alliance, TSDSI. There can be, I think I won't advocate that only you here, but I think there can be so many public-private partnership at the center of excellence, and then you bring those at these forums, because these are the forums at the highest level where we take the decisions. And even I think I have given that sectoral growth and industrial modernization, manufacturing and logistics. That's very important use case for the country like India. Logistics, I see. We need to know that how can we utilize the technology for better managing our traffic. It can be the maybe twin, digital twin. We can make it. I think some work is going on for the Varanasi. How can it should be first in some cities like the lead cell. These are the various international collaborations. So I think Bharat 6G Alliance has already collaborations with most of the leading research alliances, including XGMF. I think we learned a lot. Like to thank Dr. Iwata for sharing. And we have started with the NextG Alliance, and then 6G IA, 5G Brazil, UK, that is a research institutions, and more important has been that NGM, and that is Next Generation Mobile Networks Operators, and 5G ACIA. They are working on Industry 5.0. So now it's for us that how can we utilize them for our benefits. Sorry, I think only one slide just indicates that our members, we have grown more than 75, and it has more than 30 startups. So this is a chance for you to work with us. We are already working a document for the Department of Telecommunication that is called Accelerating 6G Leadership. And I invite all the comments if you can give us that what is your thought process for a country like Bharat? What should it take action even today to be generate 10% of IPRs or maybe 10,000 of patents, quality patents, and naturally that will be converting to standard essential patent. With this, I would like to thank our TSGSI, the host, and Mittal Sahab has been my the guru. We both started TSGSI, and there was a question that whether TSGSI should be set up or not. The question was asked by TSI, and I'm sure that now they know that no. So thank you all for patience. Thank you.
Thank you, Pathak sir. May I now request all the speakers to kindly come forward for a group photograph. Can we? Yes.
ये वो ये वाला ये speaker दिखने
We take a
mic
photo a little later. Yeah, you just have to wait. There's a question for Professor Raman.
And thank you so much. Giving me the opportunity to ask question. Small question from Professor Bhaskar Ramamurthy. So good morning. I am Amish Srivastava from TEC. So I have a question regarding coverage. Actually, we are talking about ubiquitous connectivity. So have you defined any like definition for coverage or metrics or parameter by which we can actually decide that what will be the coverage actually once we are talking about coverage? Thank you.
Who's the question for?
Yeah, so the question was for you actually.
Okay. See,
Coverage.
coverage is a problem to define very accurately because it depends on terrain. So for the same RF parameters, you can have very different coverage, as we know, in different terrains. Now the point is, the general solution in the case of cellular systems is to put more towers, depending on the terrain, so that you get ubiquitous coverage. But beyond the point, that approach doesn't work because it's not cost effective. Particularly if the terrain is difficult, yet the population density is low. So terrain could be difficult, for example, in forested areas or in hilly areas, but population density could be low. The problem in dense urban areas is that even if the terrain is difficult, you can put more towers because if the density is high, anyway, the economic viability is ensured. But in the situation where the terrain is difficult and the population density is low, that's when we tend to have coverage holes. And I think the use of NTN along with terrestrial networks, if the standardization is done so that these two can operate in a seamless manner, the NTN can have shared spectrum, and so that multiple operators can avail of the NTN, common NTN. I think there's a way to get ubiquitous coverage even in areas where the population density does not warrant a higher density of terrestrial network. So this is really the issue. It is not possible to come up with hard numbers for coverage for any technology because it's a function of terrain. Thank you.
Thank you, sir.
May I now request all the speakers to kindly come forward for a group photograph? Asif, can you spotlight on sir?